For some reason, this continues to be a hot topic, and I really don't understand the reason why when talking about vacuum advance on a distributor for timing. So today I'm going to give you 3 more things to consider when you're thinking about which style of port to use, whether it's timed or full manifold when talking about distributor timing. Let's talk about it. Sheesh. Anyone that says there's only one way of doing something is usually generally not sending you down the right path. In this case, there's 2 different options. There's the timed port and there's the full manifold port. Well, which one is better for your application? Well, before we talk about that, let's go into the workbench because I want to show you some simple math of something you may have not considered of why the timed port is still within all of these carburetors. All right, let's just take a look at some really simple basic math here because I think this will maybe give you a different way of looking at it. All of the Edelbrock carburetors, the AVS2, the Performer series, the old Thunder series, and the new VRS Race carburetor all have timed and manifold vacuum ports on it. When you look at the Holley Street carburetors, they're all the exact same way. They have a full manifold port and they have a timed port as well. Now, why is that? Are these carburetors meant to use on emissions-controlled vehicles? No, absolutely not. Edelbrock has one part number. It's the 1400. That's EO certified. That has a carb emissions designation to it. So it's allowed to be used on an emission control vehicle. Every single one of these carburetors is not EO certified. Same with the Holley. I think the Holley has a couple of different variants that are EO certified. I'd have to go take a look, but none of those carburetors are advertised as an emissions control carburetor. So why is the timed port in there? If it's only an emissions control item that's only used on emissions vehicles, why is it in there? Well, let's take a look at this at another aspect. If that was the case and Edelbrock and Holley said, you know what? They're useless. They shouldn't be used in any application at all. Let's get rid of them. Let's save some money. So let's take a look at that really quick because I want to show you some math here that may open your eyes a little bit. There's 365 days in a year, generally. When you take out all of the holidays, weekends, and everything on there, you're left with about 250 days of actual manufacturing days. Now, because there's also other considerations taken into fact with that, let's say that you've got 50 days that are removed out of there for downtime, maintenance, scheduled maintenance, whatever the case may be. So let's say now that they're only manufacturing 200 days per year. Now that's pretty, that's on the low side, but let's just go ahead and assume that because we'll be very conservative here with these numbers. 200 days a year that they can manufacture. Now I know, because I've toured that Edelbrock facility, I know pretty close to the number of carburetors that they produce every day. Can't give you that number specifically because it's a moving target. Some days they produce quite a bit more, some days a little bit less, but it's generally always the same. So let's say that in an average day, and this is not an exaggeration, they produce 500 carburetors. Pretty close to what they do in a day on average. So 200 times 500 equals 100,000 carburetors per year. Now let's take a look at the cost of including that timed port into that carburetor. It's not free. Everything costs everything. There's a cost of the nipple that gets inserted into there. There is the cost of the tooling to drill that out because it doesn't come that way finished from the foundry when these are cast. So they have to be drilled. The port has to be included in there. So that has a little bit of time and has a little bit of not really machine work on that port specifically, but you've got time, you've got tooling, and you've got how the machines are set up and programmed. All of those are real costs that are factored into a part that you are manufacturing that has multiple pieces. You've got a bill of materials of all the different pieces that go there. Every single one of those has a cost. And you've got all the assembly time of each, machining time. All of those are calculated when they are trying to calculate what their actual cost of a carburetor is. Doesn't matter if it's Holley, Edelbrock, heck, even probably the Chinese knockoff folks do the exact same things. So when we look at that, we have to take a look at the cost of each piece. So let's say each one of those little nipples cost 5 cents a piece. So you've got 100,000 times 0.05 equals $5,000 a year. This is a yearly number, cost per 5,000. Now that isn't a very big number. It's just the material cost of what's going into it, $5,000. Not that much. That's not the consideration to take into factor here. The big one is the machining time, tooling, and foundry, and all the other pieces that we talk about, how to include that in here. That's where the key piece is. So let's take that 100,000, and let's say that for that particular component, the machining of it, what it costs in the casting, the tooling, because tooling wears out that has to drill that passageway. We saw that video when I did the tour of the Sanford facility to show how they manufacture and assemble these carburetors. And I'm going to be very, very, very conservative here that is $3 per carburetor. Not unlikely. The nickel and then all the tooling, machining that is amortized into there, that is very, very I think very, very conservative. So $100,000 times 3 is $300,000 a year, okay? Now, let's take a step back. Let's say my $3 was way overestimated and I was completely wrong. Okay, 100,000 times 2 equals 200,000. Now, take that plus the 5,000 and you get either 305,000 or 205,000. That would be the savings per year by eliminating that if it's not needed. Now, let's take a look at that over a 10-year period and say 205,000 times 10 equals $2 million, $2,050,000. You are crazy to think that a manufacturer that has a very high operating costs with stuff that's manufactured here in the US, high machining costs, high replacement for tooling, high replacement for molds and casting and all the stuff that wears out over time. You are insane if you don't think that they look at that and go, you know what? $2 million over 10 years or 205,000 or even 305,000 if I was completely off is a lot of money to save per year. They would be smart to eliminate that if that was completely not relevant to that carburetor. The fact of the matter is they do not remove that, Edelbrock nor Holley, because that is a viable option for every single application that those street carburetors are sold for. Now, does it fit into every one of them? No. But I wanted to take a look at that because, again, that $2,050,000 worth of savings that they could save in a 10-year period of time is significant. And any investment company, any CEFO, or anyone that's looking at what the actual profit is on those carburetors that they make would kill to drop that out of there. So don't think that those are in there for no reason at all. They're get capped 100% of the time. They're only for emissions. This calculation tells you that that's wrong. Another thing that I think people get really confused about here when you talk about full manifold or ported time vacuum into the distributor is that they stack on top of each other. So if your initial timing on the engine is set at, let's say right now, the truck is at 16 degrees before top dead center. It's where she likes to run the best. It's where I've gotten the best throttle response. It starts easy, whatever. So yours is going to vary a little bit or could vary a little bit. I'm down here towards sea level. That's where I start. The higher you go in elevation, the more timing you're going to add. A lot of folks have said, okay, well, let's say it's 16 degrees initial and then the vacuum advance in the distributor adds another 15 degrees of timing, and then you've got the mechanical advance in the distributor that adds another 20 degrees timing. The math doesn't add up there. The vacuum timing is how it moves the mechanical timing within the distributor. They are about timing, when that hits, when the advance hits within the operation of the engine to give it the most power, the most transition, the easiest amount of throttle response, the lack of hesitation. All of those things are key factors in deciding which one is best for you. So this engine only has 36 degrees of total timing in it, and that is the timing that's in the distributor which is around 20, and the timing that is initial timing that is set, how the distributor is set in there, and how advanced that is your total timing. The vacuum advance is just a portion of that. It doesn't add to the total timing of the engine. So you're not putting 55 or 56 degrees of total timing in there when you're talking about this. It's just part of how it's moving the mechanical advance structure within there. And I think that's one of the things people get confused on is, well, we'll use the manifold side and everything will be fine. Let's talk about the next thing here, because one of the comments that I get over and over and over again is, hey, run it on full manifold vacuum because it will run cooler. Your engine will idle cooler specifically. Well, we are idling. We're about 850 is around to have that set at. And I just went on a short drive, maybe about 10 minutes. It is currently 70 degrees here. Now, let's take a look at the temperature, see where we're at. We are sitting at 170 degrees. That is where this truck likes to operate primarily. I haven't gotten into really hot days yet this year. The hottest it's been so far is 85, but the cooling system is very effective. It's a brand new crate engine. I've got a great radiator in it, good water pump. Timing is set correctly, fueling is correct out of the carburetor. Those are all factors that are going to play into engine temperature. 170 degrees. Now we are on the timed or ported vacuum. So what I will do is I will swap it over to full manifold vacuum and do the exact same thing. Well, I'll have to reset the idle speed and then go take it for a drive and let it idle for a little while and see how far that temperature drops. The timed port on the VRS is the inside one. It's the one that's above throttle plates. That one on the left is the full manifold vacuum. That's what we'll be switching to. It's actually rather hot under here, so I keep burning myself on manifold and radiator and everything else. So let me switch those over and then I will show you it all hooked up. Okay, we got the port switched around. Now we are on full manifold vacuum for the advance on the distributor. Let me fire this up. We're going to have to reset the idle speed because it will be much different under full manifold. Okay, hopefully you can hear me and see that. We're a little over the 850, so it raised about 200 RPM. Let me get that dialed back down. Little fat on the AFR. Let me see if I can dial that back a little bit too. $13.5. All right, we're a little better at 14.0, 14.1, so. Okay. She is plenty warm. Now let's go drive it anyway. So make sure that we're up to operating temperature, and then we'll check the temperature again. Back after a short trip. It's been idling maybe a minute or so here after I got back. Not that long, so long enough for it to recover if there was any issue with it. We are still at 71 degrees. It's 11:28, and we are, get the glare off of there, at still 170 degrees, same as what we were before. There is no change in idle temperature. It's not dropping dramatically. I'm going to let it sit here while we talk and see if it drops dramatically. You can see now the vacuum gauges also. Hopefully you can see those. I have both of those set to full manifold now. We'll talk about that here in a quick minute, but yeah. We'll let the moments tick by here and see just how great this idle cooling is that full manifold vacuum is supposed to give you. So far, it's not. So that's the theory anyway, but I don't think, I think just like a lot of other things, instead of it being actually something someone's experienced or shown to them, it's just a talking point, and people tend to parrot that. I don't know, but in this instance with a, it's not a mild cam. I would say it's a little more aggressive than mild. I keep forgetting the specs, so I'll put those on the screen. It's hot enough of a cam profile that it took me a couple of times tuning this to figure out which I want to do, and it ported much better. So we are still sitting here idling at 1,000. It is now 11:30, and we are still at our 170 degrees. So take the glare off there. So I know this is a sample size of one, but don't think that just because you switched it over to manifold vacuum or it's on manifold vacuum, you're getting 10 degrees better of engine cooling at idle. The reality of it is I've never seen that before. In 40 years of tuning carburetors, I've never seen that. I've never even noticed a temperature change in it. So anyone that's telling you that there's a massive degree of cooling at idle on it, well, sorry, it's just not the case. One little caveat on the vacuum advance switch from timed or ported to manifold is I did change the initial timing a few times. I went all the way down to 12. Did the exact same thing, stayed at 16. Temperature did not change at all between the two. I don't know how much timing you're supposed to take out of it to get the temperature to drop, but I will tell you that that swing didn't affect it at all, and I'm not putting 8 degrees of timing in here. That would be the dumbest thing ever. Not with today's fuel. Just needs more timing. So anyway, just throw that in there before somebody offered that up as a suggestion. Wouldn't have been a bad one, but timing made no difference. Okay, let me see if I can do this without getting into trouble. The good news is that we're not talking about a lot of mile per hour here. So what I want to show you is the tach, and the mile per hour, and then if you look at the left-hand vacuum gauge, that is at full manifold vacuum. That's where it draws from. The second vacuum gauge on the right is drawing from the ported vacuum. So you can see when the two equalize out, it's not that long. We're not talking about a long duration event here. We're talking about something that happens fairly quickly. So let's go ahead and see if we can do this and keep all the cameras on the gauges, and you'll see. So letting off the gas, we're rolling and rolling into the throttle. See how quickly? See how little mile per hour it takes to do that. So let me see if I can do that again really quickly so you can see it. And again, just going to let off the gas or let off the brake, go to the throttle, nice and easy, and then just show you how it kind of works together. All right, let's look at that again. This time I'm going to try to roll in the throttle and try to stay into it a little bit. We'll see if I can keep from wrecking the truck. See how that reacts? Completely off the throttle. Anyway, I hope you're able to see that. Still at 170. It is 80 degrees here in Memphis. Yeah, interesting. Understanding that the ported vacuum, the gauge on the right, is just going to deliver that timing a little bit differently than full manifold vacuum. When you have full manifold vacuum and the vacuum drops, you take timing away from the engine. Is that correct? Do you think that's correct? I could hook up the vacuum gauge, or I could hook up the vacuum and show it to you on a distributor and how it reacts, but as the vacuum drops, you release the advance that you put into the distributor at idle. So maybe at idle, it idles okay, low RPM it's okay, but it doesn't deliver the timing as it needs it in this engine. We'll talk about that here in just a quick second. We talk about cylinder volume and pressure and the density of the fuel and air mixture that's in there at different times, but I just wanted you to see that those two gauges read a little bit differently, and understanding is just how much timing that thing is seeing as it's going through there. Seems like it's the popular opinion these days, but no, not every engine, not every situation, not every application runs better on full manifold vacuum than it does on ported. There is not one answer that is for everything. Application, application, application. All depends on what the engine wants. Cam timing. If you have a long duration camshaft and you're generating different cylinder pressure in there, in the chambers and in the cylinders, the timing needs to be a little bit different to react to that. When you've got a lot of cylinder pressure at idle, then yeah, more pressure, it's easier to burn much quicker than it does when it's low pressure or low density within the cylinder, because it's not compressed enough, so it takes a little bit longer to jump from molecule to burn. Those things to consider when you're looking at what the engine wants for timing at idle and at low RPM, under 3,000 RPM, before the mechanical timing in the distributor takes over. So when you have less cylinder pressure, it's going to need a little bit more time to burn because it's got a longer distance to go to grab up all those molecules and burn them up and create the compression stroke or the power stroke and get fuel moving and get the expansion of those molecules, which causes the piston to get pushed down and power to be made. So you've got less pressure, then yeah, manifold vacuum probably works really well because you're advancing the timing at idle where it needs it, and you're advancing it at those lower RPMs without a lot of load or light load under the engine. All this is just, we're talking about very, very short events here when you're talking about an engine. Now, when you're cruising down the road, yeah, things are a little bit different. But, if you're talking about a drag racing application, then I don't know that I would be using manifold vacuum or ported vacuum at all. I would probably lock the distributor out, let the spark box take care of the timing, and go from there. But making that empirical statement that manifold vacuum is the only vacuum you can run on a vacuum advanced distributor is not really thinking through the situation very well. Let the motor dictate what it wants. Let the engine dictate what it needs. If it wants less timing and it doesn't need that full manifold vacuum and full advance down there at idle, then don't give it to it. If it wants it, then give it to it. But let the application dictate the terms, not somebody on the internet telling you that you always have to run full manifold vacuum. There is no other option. There's clearly two options. We know why they're there. We know that they haven't been taken out of the equation. Holley, Edelbrock, they still offer them on all those street carburetors. There's a reason for that. If they were not needed, if they were unnecessary, if they were irrelevant, they would have removed them decades and decades ago. This isn't a recent thing. This isn't something that occurred in 1970. They were included in those early carburetors, universal carburetors from Holley way back when, and the Carters from way back when. They all had ported timed vacuum on ports in there, and they all had full manifold vacuum in there. There's a reason for that. So don't second guess the build of the carburetor. It's there for a reason. Sometimes you need it, sometimes you don't. Yeah, we could do a whole other video on cylinder pressure and density and timing at off idle, through the power band, and talk about all those things. But in all honesty, it's irrelevant when you think about it. Both ports are there. If they're both there, if you have a mild or stock application, then try the ported. If you cannot get it to tune right, if you can't get it to run right at low RPMs, chances are it's not the carburetor having the issue anyway, or the vacuum advance having an issue anyway. But try it both ways if you'd like. If you find that one works better for you, wonderful, excellent. If that's what the engine wants, if that's why you've tuned it, if the AFR is reading correctly, if your plugs are reading well, then no problem at all. Then give it what it wants. But again, I think it's just very disingenuous to say that there is only one solution to this. There's not one camshaft for a small block Chevy that is the only camshaft. That's why there's hundreds and hundreds of different options. When we're talking about vacuum advance on a distributor, you got two. Figure out what the engine's asking for and give it to it. I didn't think I'd be making this video again. I quite honestly, when I did this video, I don't know, 2-3 years ago, maybe longer than that, I thought it was it. There was no reason to have the discussion any longer. You got two options, use it. Keep your comments civil if you want to talk about this down here. If you want to tell me I'm absolutely dead wrong and that manifold vacuum is the only way to do it, and if you want to make the outrageous comment or argument that it's only there for emissions when these clearly aren't emissions carburetors, they're clearly not made for OE type applications. Yeah, will they work on them? Sure, but that is not an emissions port that's on there. But leave your comments below. I just ask you to be civil with it. I know for whatever reason, I still don't understand why. This is a very hot topic, and people have really strong opinions one way or the other. But it's like anything else. I don't have one brand of carburetor that I like. I keep getting asked that question as well. What carburetor I'd recommend for everything? I don't. It depends on what it is. Right now, this has a 4150 style carburetor on the GMC truck. You can move around a little bit. Sometimes a AVS2 style carburetor is perfect for the application. Other times it isn't. So keep that in mind when you're working on vacuum advance. Leave your comments down below. Again, please be respectful of everyone else's opinion. Let them make their argument. I hope I hear something new that I haven't heard before. If you want me to do a video on cylinder pressure and how that affects timing, how that is affected by cam profiles, overlap in cam profiles, love to do that one. Just let me know down in the comments, and I'll put it on the list of things to do. Anyway, we'll talk to you guys on the next one. We'll see you.